think it would open the window. Okay, hockey team plays in an arena with a seating capacity of 15,000 spectators with the ticket price set at $14. Average attendance at recent games has been 9,500. Market survey indicates that for each dollar the ticket price is lowered, the average attendance increases by 1,000. Find the price that maximizes revenue from ticket sales. You read this and your brain goes, you're like, I don't even know where to begin. This is, yes, ask your math teacher. This is where I invoke the name of a professor I once had. Probability theory professor, and one of the worst professors I ever had. And when I took the course, he would walk up to the board each day, and he would write on the board, no notes in front of him or anything, just would straight up lecture. And sometimes the lecture was okay. The problem was the lecture often wasn't what you needed to know for the assignment or what was on the test. It's just other stuff. In fact, went in one time to ask what I did wrong on an assignment or a test, and looked at me, didn't know if I was a student in their class or not, and then once figured out I was, said, I don't really know, and then went back to working. Okay, so I won an award that year for being an excellent educator. That's when I stopped caring about awards at that point. Realized it. But he told me something I will never forget. One of the most valuable pieces of information that I ever learned from a math person. And this is excellent advice. Are you ready? When you don't know how to do a problem, just do the problem. All right. You guys all know that generally in mathematics, you feel like there's a certain trick to make the problem work out, right? There's a certain process to make the problem work out. Well, there's also just a raw method to working through a problem. He's like, just do it. I'll show you what he's talking about. We want to maximize revenue, right? Revenue. Maximize. So instead of drawing a picture, I'm actually going to model what revenue looks like. How would you calculate how much money you bring in? Look at the problem. How would you, yeah. Okay. We do not have any cost accruing here. I'm not referring to profit. I'm simply referring to revenue. Money we brought in. Yeah. Attendance is part of it. Times price of ticket. Right? That's how we generate revenue. So let's start to figure that out. Right now, what's the ticket price? $14. Times, what's the attendance? Nope. 9,500. If I multiplied that, that would give me my current revenue, would it not? So let's change it. The market survey says if we what? Buy dollar. So 14 minus 1 times, then what's going to happen? 1,000 more. So you're going to have 9,500 plus 1,000. What if we have 14 minus 2? What if we lower it by 3? This is what my professor meant. He said when you don't know how to do the problem, just do the problem. Have we solved it? No. Have we seen a pattern develop? Yeah, in fact, we could say that revenue is going to be equal to what? Give me a variable here instead of just hard numbers. 14 minus x times what? 9,500 plus 1,000x. See? When you don't know how to do the problem, just do the problem. And then you start to get a function. Revenue in terms of x is equal to, let's multiply it out. Look at this, folks. When you multiply this out, are you going to get a first, second, third, fourth degree equation? What are you going to get? Second, is it going to be positive x squared or negative x squared? Negative x squared. So what shape is it going to make? Upside down parabola. Does it have a max or min? Max. Is that what we're trying to do in the equation? Yes. See, it all comes together. It's beautiful. Yeah, let's do it after lesson. Negative x times 1,000x. Negative 1,000x squared. Negative x times 9,500. Negative 9,500x. 14 times 1,000x. 14,000x. What else do I have to do? 14 times 9,500. The same as 133,000. Can I combine any like terms? What's negative 9,500x plus 14,000x? Very good, 4,500x. Just arithmetic, folks. So, I've got r of x is equal to that. You said it makes a parabola that's upside down. So what spot are we trying to locate on the parabola? The vertex, that's where the maximum occurs. It occurs at an x value and a r of x value. So when we find x, that will be, whatever x represents in the problem. If we found r of x, the y value, that would be the revenue. How do we find the vertex? Negative b, so negative 4,500 divided by negative 2,000. What's negative 4,500 divided by negative 2,000? 2.25. What does that mean? Interpret it. You did the mathematics, but do you know what you did? Do you know what you found? X. What does X mean in the problem? The drop of the price. Amy Sanderson has it. She's a genius. 14 minus X. 14 minus 2.25 gives me $11.75. Hello. Welcome. Thank you. Naughty person right here. Saint. Did we answer the question? Do we need to know the revenue? No. If we wanted to know the revenue, what would we do? Yes, you would take and plug what into the equation? 2.25 plugged into revenue gives you the revenue. Okay. Last example. A rectangle is inscribed in a semicircle of radius 16 inches. What were the dimensions? Yes. Yep. Nope, not at all. Yes. You will often encounter problems in life where you have information that you don't need. So you didn't need to know it was hockey. Okay? So that's part of what you can see on the ACT. I often see that information pop up, and I would say be ready for that in future courses as well. So A rectangle is inscribed in a semicircle radius 16 inches. What should the dimensions of the rectangle be in order to maximize the area of the rectangle? Our goal is to maximize the area of the rectangle, so what should I write down? A equals length times width. I want to model this picture. What should I draw? A rectangle, but I want to put it inside a what? A semicircle. So I'm first going to draw a semicircle that has a radius of 16. I put it on the coordinate plane because the coordinate plane is nice because it creates these values for me that I can interpret in terms of functions. If I create a base here, I can give you guys a hint. A for the day, what's length equal to? Good try, but incorrect. 32 would be the maximum that the length could be. 2x. That distance is x. That distance is x. Yes. Yep, bxy. Because, negative xy, because this is a symmetrical. Because you're referring to you're referring to dimensions, we would always treat it as positive. If you plugged in as negative 2x, then your answer would come out negative, and you'd say, well, negative x is a negative result. So let's say you got negative 2 was your answer. Okay, so then you would say it was 4 because you would be 2 units in this direction. So you would still come up with the answer, just be over there, and you'd have to interpret it accordingly. Okay. Now this is where we separate the mice from the, I guess, men. That's not very gender friendly, is it? So here's where we separate the, it's my phone, sorry. Let's leave that go. No. Just make sure we leave that. So this probably will. Oh boy. All right. What is the height? Folks, this doesn't help me at all. I need something else for y. Because it has to be written in terms of one variable. Right now you have two. You have x and y. Everybody stand up. Stand up. No, just... All right. Very good. Now, Matthew Tate invoked Pythagoras, which is excellent in this situation. I'm going to do it, but in a different way, because wouldn't you agree that Pythagorean theorem is the same thing as the distance formula? Wouldn't you also agree that that's the same thing as the equation for a circle? We have a semicircle. Notice in the previous problem that we did yesterday, your y value had a function, 12 minus 3x squared. You don't have a function here. All I need to do is write a function. Do you remember your equation for a circle? x minus h quantity squared plus y minus k quantity squared is equal to r squared. It's the same thing as Pythagorean theorem. It's the same thing as distance formula. The center is what? 0, 0. So you have x squared plus y squared equals. That looks like the Pythagorean theorem, doesn't it? And now the radius, he told me, was 16. So what's r squared? 16 squared. 256. All right. So can you now solve for y? I can. If I subtract the x squared, I get y squared equals 256 minus x squared. You can't do that because you got a subtraction sign. So y is the square root of 256 minus x squared. So I can't take square. If there was times, I could do it. For dividing, I could do it. But addition, multiplication, you can't distribute powers over that. So area in terms of x is equal to, what's my length? 2x. What is my height? Do you know what that looks like? Exactly, we don't know. So let's turn on our calculator. Type it in. 2x square root 256 minus x squared. Zoom standard. Can't really see it, can you? So let's think about the problem. Think about x. What is the largest x could be? 16. So I'm going to change my x values to negative 20 and positive 20. Okay. Now, let's look at our y values. Y represents the area here. Okay. Let's say that this was 16 wide by 16 tall. What would the area be? 256. So we're not in the thousands. We're not in the millions. Looks like we're in the hundreds. So I'm just going to move it to 300. I just try to find something that might be a reasonable amount. Negative 300, positive 300. And I'd really appreciate if you could say, ooh, when you see this graph. Okay, ready? Kind of cool, huh? Yeah, I do too. But this is kind of neat. So we have this kind of shape. What spot are we trying to find? The maximum. The maximum occurs right here. How do I find that maximum? Second, calculate. 4, maximum. I go up to the maximum. It says left bound, so I move to the left. It says right bound, I move to the right. Press enter on guess, and I get 11.31256. You got something different? Oh, I was done incorrectly then, sorry. I've done this problem for 4 years. It's right. I could prove it using calculus. It's right. In fact, we do the same one in calculus without a calculator. So, yeah. Okay. So, what does it mean? What does it mean? We're almost done. What are you trying to find? No. The dimensions. Which one of these will help me find the dimensions? 11.31 is not one of the dimensions, but I can use it to find one of the dimensions. 11.31 is x, so what's going to be the base then? 2 times 11.31, or 22.62 inches by, how do I find the height? The height is the y value. How do I find the height? Plug what in? Plug it right in here. Y is equal to 256 minus x squared. You got to plug in 11.31. Second, square root of 256 minus 11.31 squared, parentheses, enter, 11.31. Yeah, it turns out that in order to maximize this area, you want a perfect square in each quadrant. A perfect square in each quadrant. It does. We can even prove it. Give an arbitrary radius, r, and we'll prove it all the way through. I want to bring up one last point before I tell your assignment. You don't have to take any notes on this, but I do want to point it out because I thought it was absolutely exceptional. You guys know my friend Nathan? We know that, okay? We know that. But the challenge is, can he communicate to our simple little minds the solution? So that's the challenge for him. Can he put the method of his madness down on paper for us so we can all learn from his brilliance?